Hello everyone, welcome to this online course on manufacturing processes. I'm Hari Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So already we have discussed consumable means arc welding. We discussed in last lecture. We have discussed four arc welding processes where the electrode that was being used during the welding was consumable nature. Today we are going to discuss about the resistance welding. This is different from the welding processes that we have discussed so far. In that, there was electrode, that means consumable electrode that we have discussed. Today, we are going to discuss a process that is resistance welding. Here, the source of the heat is completely the contact resistance because of the many things that we'll see. Important thing is here there will be no filler material. We are not going to use any gas. So this is completely different from that process. So first we'll see what is resistance welding. Then we'll see what are the process parameters and how these process parameters are going to affect the weld quality and other things, of course. Then we'll see what are the advantages of this process. Then we'll see what are the disadvantages of this process. And in resistance welding, which is are having different types, but which is there in our syllabus for the second year, that is resistance spot welding. So we are going to cover this one also in this lecture. So first we'll start with the resistance welding. As during the introduction itself, I told that in resistance welding the main source of heat is resistance. Resistance means it may be because of the electrode that is being used over there. These two electrodes. It may be because of the workpiece that we are. The two workpieces are in contact over there. So many parts are there which will play their role to produce this resistance. Resistance of what? This has been not shown. So this external source has been not shown. So for I'm showing here. This will be the power source here. Power source here means electrical source will be there. So what will happen? Once this will be turned on, once this will be turned on, current will start to flow in this circuit. So once current will pass through this one, what will happen? Because of the resistance provided by these two electrodes, one on the top and one on the bottom, of course it will be positive to negative, means a positive electrode and negative electrode. So these electrodes will be there, and the part that we are going to weld together, suppose these two parts I'm going to weld together, which are in contact with each other, so that will also provide the resistance to the current flow. So when current flow through this whole section, there will be resistance to the current. And whatever the resistance is, we know whenever there is hindrance in current flow, whenever a current flow through a circuit, you know there will be heat production over there. Heat will be produced. So this is the fundamental behind this process. Whatever the resistance is being provided to the current flow through the circuit, circuit means these all circuit elements, that heat is being used to melt the material where these two parts in contact. Once it will be melted, after that it will solidify and these two parts will be joined together. So resistance welding, of course, it is a fusion welding process. Fusion welding, why? Because we are melting the material. Melting the material means we are changing the state of the material. Okay, so this is a fusion welding process, or we can say a liquid state welding process that uses a combined effect of heat and pressure. Yeah, heat is being supplied because of the contact resistance and of course resistance of the other circuit element. Okay, another thing is from both side you can see here pressure will be applied. Once it will be sufficiently melted over there, then finally pressure will be applied this on these two parts to join together. So that's pressure to accomplish the joining. Heat is generated by electrical resistance to the current flow at the location to be welded. Yeah. So this resistance welding uses no shielding gases. I have already told you there will be no shielding gases, there will be no flux, there will be no filler metal. You can see through the diagram also. Nothing is being used in this process. Electrodes that conduct electrical power to the process are non-consumable. Yeah, these two electrodes, one on the top, are generally of copper, made up of copper. Sorry, copper, and of course it is of non-consumable. Non-consumable. Yeah, it will not be consumed during the process. What they are doing, they are simply in contact with this one and working like a part of the circuit. So they are conducting the electricity, but it is not being consumed during the process. So what actually happens, this is known as Joule's law. What is the meaning of this law? Whenever a current flow through a circuit, suppose this is a circuit, this is the power source, the circuit, some circuit element is here, suppose some another circuit element is here, and this is the power source and current is flowing through this circuit. Suppose current is flowing through this circuit. So what happens actually, because of the resistance provided to the current flow, this element will provide the resistance, this element will provide the resistance. So the resistance provided to the current flow plus for what time current is flowing through the circuit. What is the time? Suppose for 1 second or 1 microsecond or 10 second or 10 microsecond. What is the time? So this heat produced depends upon these three parameters. What are those three parameters? The current flowing through the circuit, a square of this one, times what is the resistance. Resistance means suppose this is the one element and this is the another element. If current is flowing through this one, these two will provide resistance to the current flow. So whatever resistance they are providing to the current, that resistor value, and for what time it is flowing through the circuit. So whatever heat will be produced over there, it will be the combined effect of these three parameters: the square of the current which is flowing through the circuit, resistance of all the elements which are there in the circuit, and of course the third one, which is for what time current is flowing through the circuit. Generally the current value is kept between 5000 to 20000 ampere. Voltage is kept below 10 ampere, and this is the very important thing to consider. The time is very less. Generally it is between zero point 0.1 to 0.4 second in a spot welding. Okay, so this is very important. These are the three parameters. What will be there in the resistance? Of course, in the resistance electrode, these two electrodes are there, their resistance will be there. These two materials are in contact, their resistance will be there because they are providing the resistance to the current flow. So this value will be there. So this current, resistance, and this time, generally this is the range. This is the range depending upon what is the thickness of the material that we are going to weld together, what is the nature of the material that we are going to weld together. Depending upon that, will decide how much force we are going to apply, how much current value will be there, what will be the time for which it will flow over there. And of course other things are fixed. Other things are fixed means resistance is fixed, because electrode from the top and bottom that we have kept here, this material is already fixed, so their electrode is fixed. This material that we are going to weld is already fixed, so resistance is fixed. So generally this will be a fix, but these two parameters we can control depending upon the thickness of the material, depending upon the nature of the material. So these two values are generally kept. This current is kept between 5000 to 20000 ampere, and time is generally being kept between 0.1 second to 0.4 second. Okay. So resistance building, this circuit is of course the sum of what are the things: resistance of the electrodes, resistance of the sheets or the parts that we are going to weld together, contact resistance between the electrodes and the sheet, of course, this contact resistance between the electrode and the sheet, and the last contact resistance between the faying surfaces, these two surfaces which are in contact. So these four elements are there which are going to play their role for this R. So these four will be there. Next, resistance and the flying surface. Okay, so now what you have to take care before the welding, you have to take care there should be no paint, there should be no oil, there should be no dirt and other contaminants over there present on the parts that we are going to weld together. So before welding, what we have to do, we have to properly clean the surfaces which we are going to weld together, so that these things should not be there. If these things will be there, all these are non-conducting, so it will create problem in circuit creation. Means what will happen, there will be no proper circuit over there. Circuit will be broken at any point. It may be, if suppose dirt is there, it will not allow current to flow properly, and also it will participate in I square RT it will participate in this value. So if we are calculating I and T on the basis of what is the thickness of the material and what is the nature of the material, if we have decided and these things are present over there, it will influence R. So whatever the parameter we have chosen for the welding, that will not be appropriate. So these are going to create the problem. So what we have to keep in our mind, we have to keep in our mind whenever we are going to weld the two parts, whichever the material we have chosen for the welding, what is the thickness and what is the nature of the material. Accordingly, we have to decide what will be the current value and what will be the time for which we are going to do the welding. Once these two things will be fixed, so these things shouldn't be there, so that there will be no role of these things in R, that is resistance of the circuit. So if we are taking resistance of the circuit, so only these four things will play their role. What are those four things? The electrode that we are using at the top and the bottom, their role will be there. Resistance of the sheets or the part that we are going to weld together, contact resistance between the electrode and the part we are going to weld together, and the last one is contact resistance between the fairing surfaces, these two surfaces which we are going to weld together. So that we need to keep in mind. If these four things are only there which are playing their role in the resistance, then these two value of two parameters, that is current and time, will be properly chosen, and then whatever the welding we are going to do, it will be up to the mark. So what is the advantage of this process? The advantage of this process is there is no filler, there is no high. If there is no filler continuously, you don't have to change all those things. So of course its production rate will be high because there will be no loss of time over there. Then we can automize this one, there will be automation of this one, and of course mechanization of this one. This process is also possible. So these are the four advantages of this process. What is the disadvantage of this process? The biggest disadvantage of this process is this process can be only used for lap welding, means this kind of welding only is possible in this one. Another restriction of this process is the on the thickness of the material that we are going to weld together. If the material is very thick, suppose 5 mm, 10 mm, that is not possible to weld by this process. So thickness limitation and limitation on the configuration of the welding, that is only lap welding. These are the two major drawback of this one. And of course setup we can consider, setup cost is also high, but two major disadvantage or the limitation of this process is, first one is it is limited for the thickness of the material, and of course it is also limited for the configuration, in which configuration we can weld the material, that is possible only in lab configuration. So next is assistance spot welding, that is there in the syllabus only in this process. So all the basics already we know. What will happen? So step wise we can see here this five steps has been shown of this process. So these are the five steps. Spot welding means no need to tell. It is not continuous. Continuous means suppose this is the one plate and this is the another plate we are welding, okay, together. So it will be at a particular speed, a spot. It is not going to be continuous, means it will not be here, it will not be here, sorry, it will not be here. This whole part you are not going to weld. Rather what we are going to do, will simply weld at this particular spot. So it will look like this. It will look like a spot. It is not continuous, just like seam welding. It will be at a particular spot. Okay, now that's why the name is spot welding. Remaining all the fundamental is same. What is the fundamental? Means how heat is generated over there through the Joule's law. We know heat production H is equal to, it is I square RT, means it will be directly proportional to the current which is flowing through the circuit, times what is the resistance of all the circuit elements. Four elements are there which is playing their role over there for the R, and for what time the current is flowing through the circuit. So these three parameters here also it is going to be same, because this is also resistance welding. On the part of the resistance welding, pressure also you have to apply from the both side. So how this process works, what you have to do, as I said, here circuit is not drawn. So this here is the circuit and here will be the power source. So what will happen, these two parts or two plates that we are going to weld, suppose this is one and this is two. So what we have to do, first we have to keep this both plate one over another, and we have to decide where we are going to do the welding, means where is the part we are going to join these two together. Okay, we'll put over there. Then what we'll do, the upper electrode and the lower electrode, first we have kept up the lower electrode, then upper electrode we'll bring it down, so now it will be in contact. So here the contact is, here the contact of course is, and these two parts where we have to do the welding. So this tip of the electrode will be there. What we have to keep in our mind, wherever or whatever the point that we are going to weld together, that spot should be clear, and that spot should be in contact with the electrode tip. That is very very important. This tip of the electrode and this tip of the electrode, it should align properly wherever we have to do the welding. The third step, this is of course positive terminal, this is negative terminal. Here the part will be. Okay, so what will happen? Once we will turn the machine and we have already fixed, we know what is the material that we are going to weld and what is the thickness of the material that we are going to weld together. So accordingly we have chosen the current, accordingly we have chosen for what time we are going to weld, and accordingly heat will be produced over there. So once heat will be produced, the part which are in contact with the electrode, this part will be melted. Okay, now once this part will be melted, what we will do, from both sides we will apply the pressure, you can see here, and this part will be completely welded where these three are in contact, these paying surfaces where we are going to do the welding, and from both electrodes from the top and the bottom. So this part will be welded together and finally we'll take it out. So these are the five step in spot welding. Remaining all the parameters are same in this one. Wow. Another thing is, what are these electrode? I have already told, generally it is made up of copper. Why copper? It should also come in mind because its thermal electrical conductivity is high, and aluminum is also having a high electrical conductivity, but relatively this is stronger as compared to the aluminum. That's why it is being taken. Okay, so it is made up of copper. Okay, or any refractory metal combination of this one can be taken. Okay, so these are the basics of this one. And now the nuggets, these things has also can be taken. The electrode tip is generally round. It may be hexagonal. It may be a square. This is very very important because it will be in contact with the workpiece. So what I told, this alignment is very very important. We need to keep in our mind where these two parts are aligned together. So that's all for today's lecture. Next lecture we'll come up with some other new welding processes. Thank you.